Hello everybody and welcome back. So this video is going to be a slight detour because what we want to do is we want to be able to write down and understand the quotient rule. But in order to derive the quotient rule in a fast manner, we need to understand a little bit about the chain rule first. And the chain rule is technically a Unit 3 topic, so we're going slightly out of order here, but no big deal. Okay, so the chain rule is all about the following: the derivative of a composition. And so we learned about compositions in pre-calculus, and you should have learned a little bit about them in Algebra 2 as well. But, even if not, we'll talk about it right here. Okay, so let's say that we have the following functions. Let's say we have f of x, which is, let's say, x squared plus 3x. And let's say we have a second function, g, which is just cosine of x. Okay. So these are two different functions, and what we can do is we can make a third function. I'll call it C1 for composition 1. And composition 1 is going to literally be the following: f of g of x. So let's look at this for a second. F of g of x means that the function g is the input of f. So, instead of x being in here, look at the difference. Here, there's the x, and so we have x here and x here. But we want f of g of x. So g of x is cosine. So basically all this means is wherever I see an x, I'm going to replace it. Okay, let me back up. Wherever I see an x in f, I'm going to replace the x in f with cosine of x, because g of x is cosine of x. Okay, so let's actually write this down now. Okay, C1 is going to be, so instead of x squared, the thing I'm going to square is g, and g is cosine. Okay, so I'm going to have cosine of x squared plus 3 times cosine x. Okay, and then we can write this in a slightly different, more efficient way. Cosine squared x plus 3 cosine x. Okay, so we still have something squared plus 3 times something, except instead of that something being x, that something is cosine. Okay, so this is what a composition is. And the chain rule, again, is all about how do we take the derivative of composition. We can also do composition 2, which is where we put f as the input of g. Nothing wrong with this. Okay? So g here is cosine of x. I'm sorry. F of x. F of x is x squared plus 3x. Okay? Now, wherever I see x in g, I'm going to replace that with the function f. Okay?
Michael Bissett, if you're on campus, please call the front desk. Michael Bissett, please call the front desk.
Okay, so g of f. So again, f is x squared plus 3x. So we're going to put x squared plus 3x in place of the x in g, which is cosine. So we're going to have the cosine of, and instead of x, it's going to be f. Okay, and f is x squared plus 3x. Okay? So that's what composition is all about. Okay? Now, let's talk about how to take these derivatives. Okay? And what we can do, I've already got C2 here. Okay. And G here, G is on the outside, F is on the inside. So here's how this works. Okay. If I want to take the derivative of C2, okay, let's just look at this for now. G is on the outside, F is on the inside. So here's how this works. We're going to take the derivative of G with respect to its input. Okay, now its input, as we can see, is no longer x, it's f of x. So this is going to be dg df, okay, multiplied by, then we're going to go inside, okay? We handled the G part. G part is done. So now we go inside, and we're going to take the derivative of f with respect to its input, and its input is right here. It's x. So dg df times df dx. Okay, so this is the chain rule. Okay, now let's write this same kind of rule down for C1. Okay, so C1, so that's in green. The form is in green here. So f is on the outside. Its input is the function g. Okay, so this is going to be df dg times, and then we're going to take the derivative of the input of f, which is g, with respect to its input. And its input, as we can see, is x. So df dg times dg dx. And notice there is this sort of symbolic cancellation. There's not a real cancellation going on here because these are derivatives, and each of these derivatives is different. But if you look, it seems like there's a cancellation here. And so if you're writing the chain rule down correctly, this type of apparent cancellation, not a real cancellation, will manifest itself whenever you write down the form of the derivative. Okay, so just for hypotheticals, let's say we have a composition 3, and let's say it is a whole bunch of functions. So f of g of h of I of x, and we'll end it there. Okay, so what would this look like, if we take the derivative of composition 3 with respect to x? This is important, dx. So we have to stop when we get here. There's the x. So first we got to go through f, and then g, and then h, and then I. So it's going to look like this. df, d, and then its input. The input of f is g. Times, okay, then we go inside by one function, okay? Take the derivative of this function with respect to its input, and its input is h. Okay, good. Now, h is a function now, but the input of h is I. And finally, the input of I is x. Okay, so this would be a very complicated chain rule situation, but the theme here, the thing that I want everybody to understand, is that when we take the derivative of a composition, the chain rule, we go one function in every time, and we always start from the outermost function. So we start from the outermost function, and we work our way in. Okay? So let's actually, now that we sort of understand the form of this thing, let's actually do these derivatives. And if you've been a little confused, I think actually doing these derivatives is going to help. Okay? So here we go. Let's do C1. C1 is this function here. Let me write this down. C1 is cosine squared plus 3 cosine. Okay. Now, what I'm also going to do, because I'm really trying to make this thing make sense, is I'm going to write down each piece again. Okay, so we had f and g. F was x squared plus 3x. And g was just cosine of x. Okay, now, if I take derivatives of these individually, the derivative of f is just the power rule. I get 2x and then plus 3. The derivative of g, derivative of cosine is negative sine. Okay? So these are the derivatives of the individual pieces. So now, let's actually use the chain rule here. So the derivative of c1 with respect to x. Okay, now, it might look like, the way this is written, it might look like that the outermost function is cosine, because that's the first thing we see here on the left is the c for cosine. But remember how we wrote it a little bit ago. We wrote it this way. As soon as I find it, here it is, right here. We wrote it like this. Okay? So the thing to remember here is that cosine squared, this guy, is sort of an abbreviated version of this one. This notation is sort of preferable when we're taking these derivatives because this notation emphasizes the fact that the 2 here, the square is on the outside. Okay? So outermost function for C1 is the square. So how do we take the derivative of something squared? Well, we use the power rule like this. Okay? Except instead of x being squared, cosine is being squared. Okay? So if I do the square part, I'll have 2, and normally it would be 2x. Normally it would be 2x, but instead of x, it's cosine. Remember, the input was cosine. So it's going to be 2 cosine to the 1, and you don't have to show the 1, but there's that. So outermost function is the square function. So we've handled that now, 2 cosine to the 1. Now we move in. After we handle the outermost function, the square part, then we move in cosine, okay? Derivative of cosine, as we've already written here, is negative sine. Okay? So there's the derivative of the first piece. And then the input of sine is just regular x. So that's how we know not to go any further. Okay? And then plus, and now we have 3 cosine. This is just constant multiple. The 3 is a constant multiple. Okay? So we can just take the derivative of cosine and then multiply it by the 3. And the derivative of cosine again is negative sine. So we get plus 3 times negative sine of x. And we're done there. Okay? So now both of these are negative. Negative 2 cosine sine minus 3 sine. Okay? And that's it for that. All right? Now, what about C2? Okay? C2, boom, cosine of x squared plus 3x. Let's write that down. And let me do this. Boop. Okay. C2, cosine of x squared plus 3x. Okay. Now, this one's different. This one is different, okay? So please pay attention to this kind of stuff. The outermost function here, unlike the last example, the outermost function here is cosine. Okay? It's not the square. The square is on the inside of the cosine. That's important to understand, okay? So again, in C2, C2 differs from C1 because cosine is the outermost function and the square part is inside the cosine. Versus C1, the square was actually acting on the cosine. So here the square was the outermost function. Anyway, let's do this. dc2 dx. Again, outermost function is cosine. So the derivative of cosine is negative sine. Okay, now The input is the function f, which I'm going to keep just like this. Okay, so I've handled the outermost. Now I go inside, okay? So I'm going to multiply by the derivative of the inside. All right, so this is going to be 2x plus 3. And that's it for that, okay? So, if you had trouble with the preliminary discussion before we got into the example, if you had trouble with this kind of stuff, then just remember outside first and then go inside one by one, okay? And you'll be good to go. All right, I'm going to call this video, and then the next video I'm going to do more examples of chain rule, okay?